Assalamualaikum and a very good evening to Dr. Nudin. My name is Muhammad Shahmi Al-Nakim bin Shamsuddin. My metric number is 203128. So today I would like to present about static for my individual assignment. Okay, so there is 4 subtopics that I would like to focus for today. The first one is the basic concept of static. The second one is force system, and the third one is equilibrium. And last but not least, analysis of friction in bodies and structures under static condition. So let's go for the first subtopic. What is static? Static is the branch of mechanics that is concerned with the analysis of loads, force and torque, or moment acting on a physical system that do not experience an acceleration, which is A equal to 0, but rather are in a static equilibrium with their environment. Static consists a fundamental concept which is known as a basic quantity. So this is the example of the physical quantities that is being used in static subject. In static, Newton's 3 laws of motion are very important. The basic laws for the displacement of a particle were first formulated by Newton. So the first law of Newton is known as a law of inertia. The first law states that when a body is in motion, is at rest unless until it is forced to change that state by force imposed on it. The property with which a particle resists a change in its state of rest or movement is called its inertia. So, Newton's first law is therefore also known as the law of inertia. As you can see the example in the picture. Okay. Next is second law of motion. Okay. Second law of motion states that the rate of change in momentum of a particle is proportional to the force applied to it and takes place in the direction of that force. Second law is defined by the following formula. So F equals to ma, which is F equals to force, m equals to mass, and a is for the acceleration. Okay. The third law of motion states that for every action there is an equal and opposite reaction. If a body A exerts a force on a particle or body B, it will exert an equal and opposite force on body A. For easy example, we can see from the shooting a bullet. Okay, shooting a bullet, when you release a shooting, the gun will going backward and the bullets will uh, going forward. Okay, so there is a equal force. Okay. Next is the Newton's law of gravitation. This is the just additional information. Okay, this law states that two particles of mass m1 and m2 are mutually attracted with equal and opposite force of magnitude F given by the formula. Okay, as you can see in the picture, mass 1 and mass 2 going in the same direction. So the force, the positive force and the negative force. So the formula is F equals to G m1 m2 over r square. R is the centroidal distance between the two particles. Okay, and the G is the universal constant of gravitational equal, which is 6.673 times 10 to the power negative 11. Okay, next. Okay, we move to the second subtopic, which is a force system. Okay, force. Force is defined as the cause of change in the state of motion of a particle or body. Force is represented as a vector, an arrow with its magnitude. Okay. A force has following basic characteristic. The first one is magnitude, direction, point of application, and line of action. Okay, as you can see, the dot line from A to B. Okay, this is the example of force. The force have a magnitude of 4 kilonewton. Okay. Then what is the force system? Okay, when a mechanic problem or system has more than one force acting, it is known as a force system or system of force. Okay, force system is divided into two, which is coplanar and non-coplanar. While coplanar have a four different type of force, which is collinear, parallel, concurrent, and non-concurrent. Same goes to non-coplanar. It has three different force, which is parallel, concurrent, and non-concurrent. Okay, let's go into the details of the force, type of force. Okay, the first one is collinear force system. Collinear force system states that when the line of action of all the force of a system act along the same line, this force system is called a collinear force system. Okay, the next one is parallel force. All of the action lines are parallel. The third one is concurrent force system. The force when extended pass through a single point, and the point is called point of concurrency. The line of action of all force meet at the point of concurrency. Concurrent force may or may not be coplanar. Okay. For the coplanar force system, when the line of action of a set of force lie in a single plane is called coplanar force system. Next, when the line of action of all the force do not lie in one plane, it is called non-coplanar force system. For the non-current force system, the force of a system do not meet at a common point of a concurrency. This type of force system is called non-current force system. Parallel force are the example of this type of force system. Non-current force may be coplanar or non-coplanar. Okay. Next is resultant force. Force is a vector quantity which is have a unit of Newton. Force also can be known as a vector addition or vector subtraction. A resultant force is the single force which represents the vector sum of two or more force. For example, two force of magnitude F1 and F2 acting upon a particle have a resultant as shown in the example. So, F2 for the y-axis and the F1 is for the x-axis. Okay, we move the F1 to the right to create a new line which is called a resultant force. Okay, in order to add two force together, the start of second force need to be moved to the end of the first force. Okay, the resultant going from the start of the first force directly to the end of the second force. Same what I said just now. Okay, next. Okay, to calculate the resultant force, there is important rules that we need to know. Okay, so the first one is Pythagoras theorem. Okay, I expected that we have learned this from secondary school, so there is no problem for us to remember the formula such as sin A, opposite hypotenuse, cos A, adjacent hypotenuse, tangent A, opposite adjacent. Okay, so the Pythagoras theorem have an equation that s square plus b square equal to c square. Okay, the second rules is complementary and supplementary angle. These also have been taught in the secondary school, which is for the example 100, this one. The line resultant force has an angle of 50, so the total angle for this surface is 180. So 180 minus 50, we get 130. So this is a basic knowledge that we should have to study and to calculate the resultant force. Okay. Next is law of sine and law of cosine. Okay. This formula we should remember because this is very important in order to calculate the triangle. Okay. So law of sines have a formula sin A over A equals to sin B over B, sin C equals to sin C over C. Okay. I think law of cosine, you can read the formula. Okay, next we go to the parallelogram rule. Parallelogram rule, which is P vector and a Q vector. Okay, as you can see, P vector going to the right and the Q vector going upwards. Okay, so in order to get the resultant force, we create a line in the middle of them. Then we add a new line, which is B to C and A to C. So we can use this parallelogram rule to find the exact angle. Okay. Okay. I would like to give some example so that you will be more clear about the resultant force. Okay. So example 1, let's see together. The screw I is subjected to two force F1 and F2. Determine the magnitude and the direction of the resultant force. Okay. So as you can see, F2, which is line from the center to the upward, we have equivalent to 150 Newton, and we have angle 10 degree. While F1 equivalent to 100 Newton, and we have the angle is 15 degree. Okay. So the best way to calculate the resultant force is that we apply the parallelogram law. Okay. So we sketch the FBD, free body diagram. So we add a new line to complete the parallelogram law. Okay. Okay. Next, after we get the value of the resultant force, okay, we use the law of cosine to calculate the resultant value. So which is we get 213 Newton. Then after we get the value of the resultant force, we use the law of sine to calculate the angle for the resultant force. Okay, so the theta we will get the 39.8, but the theta is not actually the angle. We must add the 15 degrees from the F1 value. So the total angle we get 54.8, and the resultant force is 213 Newton. Okay. Okay. Next, we move to the addition of a system of coplanar force. Coplanar force resultant. To determine resultant of a several coplanar force, resolve force into x and y component. Addition of the respective component using scalar algebra. Resultant force is found using the parallelogram law. Cartesian vector notation as the F1 equals to F1 Fxi plus Fyj. Same goes to F2 equals to negative F2i plus F2j. And then F3 equals to F3s I minus F3j. Why some of the vector become negative? It follows the direction of the force, such as for the F2, for the I value, which is x-axis, it moves to the left, therefore it's negative. While for the J, on the y-axis, it moves to the upward, therefore it is positive. Okay. Then vector resultant is therefore we can simplify as F1 plus F2 plus F3. So that is the resultant force. Okay. If the scalar notation are used, FRS equal to F1S minus F2S plus F3S, while for the y-axis equals to F1Y plus F2Y minus F3Y. In all case, we have that the submission of Fs equals to FRS, while the submission of Fy equals to Fry. Okay. Remember to take note of the sign of convention. Okay. Okay. Magnitude of resultant force can be found by the Pythagoras theorem. Okay. After we use the Pythagorean theorem to find the resultant force, then we can find the theta by using the Pythagoras theorem law. Then such as theta equals to tan -1 Fry over Frs in this example. Okay. Okay, next I would like to show you the second example. Okay. The question is determine X and Y components of F1 and F2 acting on the boom. Express each force as a Cartesian vector. Okay. As you can see, the F1 is equal to 200 Newton and has a 30-degree angle, while the F2 is going downward. Okay. And has a force equivalent to 260 Newton. But we have a clue that the triangle have their own ratio, which means the hypotenuse, adjacent, and opposite value 13, 5, and 12. Okay, so we can use the information to calculate what we going to search in the question. Okay. Okay. For the scalar notation, okay, F1S equals to negative 200 sin 30 Newton, okay, equals to negative 100 Newton, equals to 100 Newton. Okay, next for the Fy, 200 cos 30 Newton equals to 173 Newton equals to 170 Newton, follow the direction. Okay. Next, we find the theta. Tangent -1 times 5 over 12. Okay. Then we get the Cartesian vector notation, which is F1 equals to negative 100I plus 170 J Newton, while F2 we get 240I negative 100 J Newton. Okay. Okay. By similar triangles, we have F2 equals to 260 12 times 12 over 13, we get 240 Newton. While for F2y equals to 260 times 5 over 13, we get 100 Newton. So for the scalar notation, we get 240 Newton to the right, while for the y-axis, it becomes negative 100 Newton because the force is going downward. So the finalized answer is F1 equals to negative 100I plus 173J Newton. F2 equals to 24I negative 100J Newton in the Cartesian form. Okay. Next, we move to the third subtopic, which is equilibrium. Okay. Okay. Equilibrium of a particle. Okay, it is defined as when the resultant of all force acting on a particle is zero, the particle is in equilibrium. Okay, the condition must satisfy Newton's first law, which states that a particle is in equilibrium if it is at rest or move in a straight line with a constant speed provided that no external force exerts on it. Okay, so the resultant force is the equals to submission of force equals to 0. For the example, polygon of force. Okay, polygon of force ends at the same point as the start point, which means the resultant force of force is the system is 0. The particle is in equilibrium. They move in the same direction from 18 kilonewton to 9 kilonewton to 7.8 kilonewton, and it meet again to the starting point. So therefore, the force in the system is 0. Okay. Next, free body diagram. Okay. Free body diagram is very important in order to show and to get easier visual of the question. Okay. Free body diagram of particle is a sketch of the particle which represents it as being isolated, free from its surrounding. On the sketch, it is necessary to show all the force that act on the particle. Okay. The method to sketch the free body diagram is choose a significant particle, then draw a separate diagram showing the particles and all force acting on it. Example, the first picture, we have a cube, we have a spring, then we transfer this diagram into free body diagram, which is we get into the second picture in the x, y plane. Okay. Free body diagram is of primary importance for solving problem in mechanics. Okay. Okay, next is weight and the center of gravity. Resultant force due to gravity for the entire body is known as the weight. The location of the point of weight is at the center of the gravity. If the body is uniform, the center of gravity is located at the centroid. Okay. Okay, for the example, the first picture at the top. Okay. The center of the gravity is at point A because there is a tension going upward and the tension from A to C and A to B. So that is the center of gravity that called centroid. Okay. Next is frictionless pulley. The force in the cable that runs through a frictionless pulley is constant. Okay. Like example in the picture. Okay. Next, spring. When linear elastic spring is used as support, the magnitude of the force exerted is followed as the equation, which is F equals to Ks, which is K is the stiffness and spring constant, while S is the deformation of a spring. Okay. Okay. Next is coplanar force and three-dimensional 3D for system. This already we explained just now, but I just want to clear about the Cartesian vector for the three components. Okay. Let's say if we have three components. So the three components is for the x-axis is I, for the y-axis called J, while for the z-axis is called K. Okay. So the submission of the all plane such as x-axis, y-axis, and z-axis must be equal to 0. Okay. Okay. The sense of direction of each component is accounted by an algebraic sign which correspond to the arrowhead direction of the component along axis. The arrowhead sense of a force of an unknown magnitude can be assumed. If the solution produced as a negative scalar, it indicates that the sense of the force acts in the opposite direction of the assumed direction at the beginning. Okay. Okay. Let's see the example 3. The question given a 100 kilogram crate as shown is supported by 3 cords. Okay, 3 cords is the 3 tension. One cord has a spring in it. Okay, which is for the B cord, we have a spring on it. Okay, the question asks find the tension in cords AC. Okay, A is the centroid, AC, and AD, and the stretch of the spring. So he asks for the stretch of the spring. So we must extract first the data. Okay, then we must uh, point all the ideas that we have. First, draw a free body diagram of point A. Let the unknown force magnitude be FB equals FB, FC, and FD. Okay. Second, represent each force in the Cartesian vector form. Okay. The third one is apply equilibrium equation to solve for the 3 unknowns. And lastly, find the spring stress using the formula, which is F equals to Ks. Okay, next. Okay. First, we sketch into the free body diagram. For the crate, weight is equals to 981 Newton. So, for the FB, we must convert all this force into Cartesian vector component. Okay. So, FB equals to FBI. Okay. Because the force only on x-axis. There is no force to the upward or in the z-axis. Therefore, the FB equals to FBI. Next, FC equals to negative 0.5 I negative 0.077 J plus 0.5 K Newton. So for the FD, we have negative 0.333 I plus 0.667 J plus 0.667 K. Okay, this information we get from the A to D that has information about the height and the length, which is 2 meter height and 1 meter length. Okay, so we can use the information to calculate the force from A to D. Okay, after we get all uh, the equation for FB, FC, and FD, okay, we must use a simultaneous equation to find the force for each, for the FC, FD, and FB. Okay, next we get, after we use the 3 simultaneous equation, we get FC equals to 813 Newton, FD equal to 862 Newton, FB equals to 693.7 Newton. Okay, then we find the F equals the spring stress using F equal to Ks. Then we arrange the formula S equals to FB over K. Then we get the answer is 0.462 meter. Okay, let's move to the last subtopic for today. The analysis of friction in bodies and structure under static condition. Okay, there is a 5 friction analysis that can we see for today, which is the first one is dry friction, flatbeds, wedges, rolling resistance, and screws. Okay, the first one, before we go to into the details, let's understand the concept of friction. Friction is the force resisting the relative motion of a solid surface fluid layers and material elements sliding against each other. Okay, there are several types of friction. The first one is dry friction, is a force that opposes the relative lateral motion of two solid surfaces in contact. Second one is internal friction, is the force resisting motion between the elements making up a solid material while it undergoes deformation. The third one is lubricated friction, is a case of fluid friction where a lubricant fluid separates two solid surface. Skin friction is a component of drag, the force resisting the motion of a fluid across the surface of body. Lastly, the internal friction is the force resisting motion between the elements making up a solid material while it undergoes deformation. Okay, so what is drag friction? Drag friction is the force that opposes one solid surface sliding across another solid surface. Okay, drag friction always opposes the surface sliding relative to one another and can have the effect of either opposing motion or causing motion in bodies. The first example, as we can see, for the rugby scrum. Okay, the rugby scrum, when we push forward, the grass remain constant. Okay, so the friction is occurs because the force is opposite. Okay, then we can see the example, to force pushing on book. Okay, example, we push a book on a table. Okay, the book going forward while the surface, the table, remains static. There is a friction force for the reverse. Okay, opposite the applied force. Okay, and the third example is riding a motorcycle on a road. Okay, as the motorcycle going forward, there is a frictional force going backward, which is the road. Okay. Okay. Next is wedges. Wedges is a simple machine in which a small force is used to lift a large weight. Okay. Usually, the wedges always used in the petroleum, in the construction. Okay. The friction force are always in the direction opposite to the motion or impending motion of the wedge. The friction force are along the contacted surface. The normal force are perpendicular to the contacted surface. Okay, as you can see, the middle, as you can see the middle picture. Uh, this P arrow shows the wedges to lift uh, a big something big. Okay, then we transfer this diagram into this free body diagram. Okay, as you can see, there is too many force. The first one is force from bottom, and the second one is force from top. It also has mass on it, on the wedges. Okay, wedges are used to adjust the elevation or provide stability for heavy subjects such as this large steel pipe. Okay, as you can see in the red circle in the picture. Okay, next, the screw. The square trap form is a common screw trap form used in high load applications such as a lead screw or jet screw. A lead screw, also known as a power screw or translation screw, is a screw used a linkage in a machine to translate turning motion into linear motion. Okay. Because of the larger area of sliding contact between their male and female members, screw threads have larger frictional energy loss compared to other linkage. Okay. As you can see in the picture, the weight going downward while the force is rotation. Okay, going rotate. Okay. The advantage of the lead screw it have a large load carrying capability. It is compact. It also is simple to design. Last but not least, it is easy to manufacture. No specialized machinery is required. Okay, so the screw is very important uh, in the industry such as. Okay, next is rolling resistance. Okay, rolling resistance also help to reduce friction. Okay, rolling resistance, sometimes called rolling friction or rolling drag, is the force resisting the motion when a body such as ball, tire, or wheel rolls on a surface. It is mainly caused by non-elastic effect that is not all the energy needed for the deformation or movement of the wheel rod bed is recovered when the pressure is removed. Okay. Uh, like in our daily life, car, we use a tire that shape uh, in circle, right? Why we use a circle? Because uh, it is easier to move. If we use the tire in square shape, so there is more friction on it and it cannot move. Okay, so the rolling resistance can be expressed by the generic equation, which is Fr equal to Cw. Fr is the rolling resistance or rolling friction. C is the rolling resistance coefficient. Okay, while the W is equals to mass over Ag. Ag is acceleration of gravity. Okay. Next is flat belts. Okay. Okay. So flat belt is like a pulley. Okay. Flat belt are designed for light duty power transmission and high performance conveying. They have a power, transmission, efficiency, are cost effective and easy to use and install. Belt friction is a term describing the friction force between a belt and a surface, such as a belt wrap around a bollard. When a force applies a tension to one off end of a belt or rope wrapped around a curved surface, the frictional force between the two surfaces increases with the amount of wrap about the curved surface. And only part of the force or resultant belt tension is transmitted to other end of the belt or rope. Okay, as you can see in the first picture, if the rope has the same length, okay, therefore the tension is equal T1 equals to T2. While for the second picture, if the second rope is more longer than first rope, the tension is higher in second position than first position. Okay. Okay. So this is the flatbeds in real application. Okay. So that's all from me. I hope you guys understand. Okay. So thank you so much for spending your time. Okay. Bye bye.